What up, guys? Hope everybody is getting ready to have a great Thanksgiving. Hey. Since I was just drawing, I might as well hop on live, see if anybody wants to talk, or hang out, or whatever, or questions, or any of that junk. So no, Thanksgiving is tomorrow in the U.S. Yeah. Where are you out of? Actually, haven't you been on? You've been on one of my lives before, haven't you? Leeds. I stopped by there when I did my Europe thing this last year. Let's see. 106. Oh, I said when I did my Europe thing this last year, I traveled through there and I basically had to switch trains. It was pretty. Actually, all of Europe I thought was awesome. And I know. I hear people bitch about the train system you guys got there, but, dude, I thought it was amazing. I mean, I was there for a little over 2 weeks. I did that talk at Maker Central in Birmingham, and, I went all the way up to, Edinburgh, and then over to Glasgow, then back to Edinburgh, down to London, and then to, where was the other place I went? Where Open Bionics is. And, I was able to get all throughout the country without really anything. I didn't do cars for that entire didn't do cars for that entire time I was traveling abroad, and it was awesome. Bristol. So Bristol's where I went. Yep. Stayed at what's that? What's the hostel there that has the starry sky painted on the side of it? Stayed there, and that was awesome. Actually, when I did the Europe thing, I only stayed at hostels, and that was the best time. Because like if you stay, if you travel and stay in corporate housing, you know exactly who you're going to meet, which is nobody. And I mean, you got to meet kind of anybody, everybody, and you never had any idea of who you were seeing that night. It was cool. It was so cool. But in the U.S., we don't have that type of thing. You know, we have hostels, but it's not the same feel at all. Awesome. Huh. Well, I mean, what I really liked about it was how cheap you could stay. I mean, you know, you get a room for like $30 a night. You know, compared to corporate housing is, you know, 100, 100 and a half a night. So I thought that was pretty good. Oh, well, I don't know. Everybody seemed to be pretty cool. The funny thing was the amount of people that I met that were either aware of my channel or... So I don't know. I haven't got the invite from Maker Central yet. But that usually comes around like first, second week of January. And this year I'm doing Super Bowl. I'm back to doing Super Bowl again, so I don't know, we'll see. I'd love to. I'd love to. It was a super fun gig this last time. Let's see. Today I am working on the new forearm cuff with ISO grid. Hopefully this will become a thing that is 3D printable, and then it'll become one less super custom part. So, and then like, you know, this will be a bolt and a strap connection going to the other one that's blocked out, and then I can go back to wearing a watch on that one and then just a regular strap over on this side. But it's getting the load translation from these points to the gimbal. I have a gimbal being printed over on my K1. I just have crap getting printed on the S1 from FL Sun. It's kind of new printer season here right now, so which is pretty cool. So let's see. I want one right there. Probably parallel to that. So when you start so for the last couple of years I've been dealing with a lot with Creality, and they've been great to work with. But lately, you know, FL Sun reached out to me, wanted to give me one of their printers, and I've been working on that deal for quite a while, really. And I don't know, they're pretty okay to work with. You know, they haven't been, I mean, they were bugging me a little bit for the video, but not like super bad. You know, the K2, I need to make another update video on the K2. I've been really happy with it. You know, it's a good printer. Just, you know, it seems like their release, when they did the release of the product, I think they really goofed that up. But, you know, because all of the creators, we ended up having them for, gosh, probably a month before we were supposed to do videos, and then they kept moving when they wanted the videos. You know, so it would interrupt our our video schedule. You know, and then it was, you know, well, we want it now, or, you know, we don't. Then they'd set a date and then move the date. That was kind of frustrating. I don't know. Some of the other creators were more wrapped up about it than me. I didn't care. I figured they were, you know, you already agreed to put out a video. Oh, absolutely. Well, because then I can actually go, hey, I have, you know, 20 days worth of use on this. This is how this thing is starting to age, you know, and these are the things that I'm starting to see being issues with, you know. I mean, it's like, okay, so like for the K2, you know, they do an update about every other week. There's a firmware software update on it. And don't get me wrong, it's a great printer. I mean, it's a Core XY. I mean, Core XYs can only do just, I mean, they're just doing Core XY junk. But, like the automatic backup filament feature, when they initially released it, that feature was awesome. You know, so first thing I did is I ripped all the little stickers off of the rolls, so it didn't know what filament was in it. Just because I'd rather have more of a dumb machine than, you know, something that's, you know, it's where you could tell it that all the filament is blue, because it doesn't matter as long as it's, you know, as long as it's all PLA or whatever. But that's how I was getting rid of partial rolls, you know, and you just have it do backup to backup to backup. And that feature used to work so awesome, and now it's really kind of hit and miss. And that's kind of frustrating, you know, when they have something that's perfect and then they go and screw it up. So, I don't know, I've been still kind of on them about that. But, you know, whatever. Let's see. Let's go 0.1 for a 0.2 hole. Right now I'm designing the top and bottom plates for this that will go to the gimbal one. So this ends up lining up like this, and then there's two bolts boop, boop, that go there, and then that'll just be a top and bottom plate. And then same thing for the other side, in those two filled in slots on the ISO grid. So just on those up real quick, then I'll send them to one of the printers, and then that will be awesome. So we're going to go 0.1. Maybe a little less. Oh, it does. Oh my gosh, the ISO grid adds so much strength to this. I mean, so the ISO grid's width is 150 thousandths, so that'd be what, 3.5 millimeters, and it's 5 millimeters thick, and then the cross section of this is right at 2.5 millimeters thick, and I mean, this is so stiff. These should, but I don't know. So I did one of these where it was an early before I went and rescanned this one, and it was the neon green with the black ISO grid. It looked so awesome. So it looked like it was basically that. And I mean, if I could replicate that, that would be so awesome. I mean, you just have to paint the bottoms of it, but you know, then it becomes a thing. But like when I have Cerakote go and do the parts for me, I think that's what I'm going to end up doing, is just have them go ahead and paint those. I think that'll be awesome. let's see. We'll scoot this over about 50 and then down. Yeah, probably about there. Yeah, so I mean, you know, I would do it as orange and black. Have the other shell. Here's the other shell, but I thought that looked pretty good. See, and trim. Connor. Is that Jack? Or is it a different Connor? I doubt that I'm gay, but whatever. Well, that has finally kicked off. Cool. I lost my hand due to bone cancer. Bone infection after a stem cell transplant for multiple myeloma, which is a hematological... Printer just ate itself. Hold on. Sorry, it's printer ate itself. I use a software called Project CAD. It is, I used to use AutoCAD, like legit AutoCAD, but then my permanent standalone license became invalidated. So the nice thing about Project CAD is you own it. So it's like $500, and it's not a subscription or, you know, anything. You own it forever, and you update it whenever you decide that they've come up with something that's going to be beneficial to you. We will try that again. Extruder stopped. That's the first time that's happened on. Yes, that is the software. It's Project CAD is the CAD side of it, but Progisoft is the parent company. And I mean, the tool package is just like AutoCAD PDSU, Product Design Suite Unlimited. It's exactly like that. And I've been using it for, this is my second year using it. And it's great. It interfaces with all my CNC equipment. My plasma cutters understand all of the drawings. So it's awesome. So I export it as a DXF, and then I use Mach 2. Mach CNC systems, and they have a DXF to G-code generator. Now this is for like just the plasma cutter and the laser and that type of thing. For milling machine stuff, I use software called BobCAD. It's okay. They were bought and sold a couple of years ago, so like I'm running like super old software from them. And it's okay. If I could find another alternative that was cheap, I would switch. Their drawing side of the software absolutely sucks, but their G-code generation for like the milling machines and stuff works great. But they want way too much for the software now. Yeah, the only thing I don't like about... So if you were to downgrade from Mach 3 to Mach 2, you can take DXFs directly from AutoCAD and input them onto your machine. Like, you don't have to do a converter or anything. Oh, I didn't even catch what he said. I just try to ignore when people get twisty like that. So I didn't like sheet cam. It felt so... It didn't feel finished. For another one that uses Vectrax, they're from the UK, for like my wood machine, and there's a company in Middle California that I take care of. They run Vectrax on that machine too. Yep. Let's see. I'm gonna undo that. Or maybe it's Vectrix. I think it's Vectrix. Or Vectric. That's what it is, Vectric. It's a software that comes for ShopSaver brand machines. I think that's who they're partnered through. Let's see. Point 2. Okay, we're gonna just radius that 0.2. We'll do 0.22. Heck yeah! The thing is, that machine, God, I think I built that system in like 98, 99. I'm still running the same computer from back then. And, I transfer everything off of thumb drives. So it's not like it needs to ever get on the internet. I had it networked connected just for the milling machine, the plasma cutter, the lathe, that type of thing at one time. And I found that I didn't use it as much as what I thought I was going to. Oh, I do everything in SAE, but I have a couple customers that I have to convert it for because we get drawings out of the Netherlands, which is fine. I don't care, but no, my native dimensions are an inch standard. But I'm one of those guys that, can do the convert on the fly. All right. So, I think that's going to work. So we'll do 2 of those. So, like a lot of this stuff, I go down to the thousandths. And, whereas if I had to do that in metric, I would have more of an issue trying to keep everything straight in millimeters. I mean, I think that's just because, I grew up SAE, so. I just natively know, what 10 thousandths really looks like. Whereas, a 1/10 of a millimeter, I know that it's 3.4 thousandths, but still. Let's see, we're going to do that as 0.0, and as a 440, so 0.45, another 0.45, huh. Right? No, exactly. Exactly. I mean, really, it's only been in the last probably 10 years. Well, no, I'm going to go probably the last 5 years where I've started really doing a lot of things in metric. I started doing a lot of awesome. I started doing a lot of stuff for people on the other side of the world that I started to need to be able to just be able to convert, metric pretty well on the fly. Okay, so we're going to go that probably, what, 90, 100? 0.1, and then that's going to be 150, so that's 250. And that'll be another 250. And we are going to subtract. Boop, boop. And then, no, we're going to add those. We're going to add those and subtract the other. That's awesome. So, Union. So on the Project CAD, I can draw, I do all of my 3D generation, like all my model generation for 3D printers and stuff. I do all of that in ProjectSoft without any issue. So something to keep in mind. All right, and those are going to be probably 3mm, so 0.055. Okay, and that is all the surface, and subtract. And then we're going to extrude that to be 100. Okay. So this is the first piece that isn't CAD generated. So the way I did this, I took my ferret scanner, stuck that in my rotary rig, scanned my forearm, stuck that in mesh mixer, extruded a shell, printed off the shell, and then laser cut the ISO grid, and then super glued the ISO grid onto this, scanned this again, and then printed it. But everything, like the fingers, the winder, the gaffney, the gimbal, all of that's in CAD. In fact, I'm printing one of the gimbals, this piece right now, just so I can have something to work with on this to get the spacing of the flanges right. And right now I'm making the top and bottom plates for this to go onto that gimbal plate. So we got the one, and where'd the other one go? Oh, here it is. So this is just EVA foam, 5mm EVA foam. And what I did is I cut this to shape, and then I just super glued it onto this. Just super glued it onto the shell, and then scanned it. Because doing it that way is way quicker than using plasticity. Because normally for like the organic shapes, like the fingertips and stuff, I use a software called Plasticity, because it has an Xnerves platform to where you can just do rails and styles, and then it'll surface the rest of it, which is super awesome software. So and I think that's like $300. Again, it's a forever software, so that's super awesome. I'm way into the forever softwares instead of the subscription thing. I think subscription totally sucks. Alright, so that should be 60 degrees. Oh, is that what it is? Yeah, there's a bunch of videos on it. I've been really happy with it so far. Okay. So 60 degrees. Yeah. So the 150 was for like a studio license or something like that. You're starting to make noise. Or hello. Let's see. We're going to be 6 degrees and 0. So I'm actually going to work from the center line on that, I think. We'll go and rotate. And there, and rotate trim. Up. I am drawing parts for the new forearm cuff idea. Oh, super awesome. Coming up for second week of December, one of my guys that is going to be trying out my hand is coming to visit. And he's going to try it on, make sure he likes the feel of it. Make sure it's going to work for him before he gets a bunch of time and money invested in it. So, hopefully I'll do a video with him. Because this is on my phone. So, I don't know how I could really do that. Let's see. How could I do that? I guess I could go live with myself. Yeah, I don't have OBS on. No, I'm running Samsung. But I could probably, I will go get my other phone and I will go live with myself. I mean, I don't know how well that's going to work, but maybe it'll work. I just have to be sure to log in on my other account. It'll either work or it won't, huh? Let's see. Huh. Switch accounts. Okay. Okay. Now, how do I go live with somebody? Can I go live with somebody when I'm... Not that button. Wonder. Let's see. Well, good luck. Good luck on that exam. Okay. So if I go live, well, that sucks. I can't go live on my other account because I don't have enough followers. Shoot. It probably is going to break it. Let's see. Okay. I know what I can do. Oh, that's what I'll do. How will that work? Okay, I'll unplug those monitors, and then I'll turn the big monitors on and move all of I'll just have you facing this way so you can see the screens behind me, and I will duplicate the screens behind me. How about that? That'll work. Okay. Okay. Now we need to get rid of... We're going to get rid of this screen. And we're going to get rid of this screen. Right. Okay. So we'll go to display. So display. Okay. Okay, those are off. So identify 2 and 3. Okay, so this one needs to be rotated portrait. No, not that one. Revert 3 is portrait. Wrong way. Portrait inverted. Revert portrait inverted. Keep, and then 2 is portrait. Keep changes. Okay, that looks about right. And then we're going to do... Okay, that's going to be 1080. This is going to be 1080 as well. I think they're both supposed to be 1080, 1400. Maybe. No, 1080, 1400. 1080, 1920. That's what it is. That's what it is. What's that? Alright, so everything's groovy there. And then I will duplicate on 2 and 3, except for they're on the other sides. Identify 2, 3, 2, 3. Okay, so that isn't what I need to do. So only on 2, keep changes. Extend. Extend on 2 and 3. Yep. Well, so my mirror monitors over there they're 1080. These are 4K screens, so I have to go with the lower. I have to go with the lower resolution. Otherwise, it has problems because I'm doing a splitter, or I'm doing a switch, because I have a computer that runs these screens during videos, unless I'm doing something laptop related, and my mirror screens, my monitor screens, are just 1080. So I have to go with the lowest resolution of those two, because that's just a splitter between these two. So, I'll just work off of the mirror monitors. That's what I'll do. And then you guys can see that too. That'll work perfect. All right. So, boop. Oh, now that's screwed up again. All right. Oh, we're so almost there. Okay. So, got to flip those again. So, landscape, I think that's flipped. Nope. Other one. Landscape. Portrait. Yep. And then we'll go portrait on the other one. Portrait flipped on this one. Keep changes. Okay, everybody's facing the right direction. And then we will just move CAD. Oh, look at that. Oh, that's going to be perfect. And then scoot that down. Oh, you'll love this. Okay. So, now I just need to undo how I have it mounted to the wall, because the USB cables aren't long enough. All right, do a couple clips and we will be there. See what I do just for you guys? Okay, and undo this one. Well, you see, normally I'm not sharing my CAD screen with YouTube. So, of course, I mean, if everybody likes it, maybe I'll just do it this way for from now on. Okay, so I don't need that. I will just move this over here, and then this can come over here. Okay. We'll move all of this, all of that. Okay, don't need that. Okay, we aren't doing... Oh, yeah, we aren't doing that one. We aren't doing that monitor. We aren't doing these. Just don't need those. What we have here. Don't need that. Do need this. Okay. So I can be right there. And then you guys can be right over there. All right. Hold on a second. You guys are almost there. Let's see. All right, hold on a second. Tighten that up. All right. So there we go. Can I get rid of, let's see. Oh, that's this one. Hold on a second. I will get rid of that reflection. There, all better for you guys, right? Awesome. Okay. All right, so I am drawing off of these, so you can see there. All right, so this is, actually, I guess I don't, I only kind of need that. All right, so these are the top and bottom plates that are going to go onto this, and they interface to the gimbal piece. So this goes like this, and then that is going to go like that. That's what those two pieces up there are. Now we're going to draw the ones for the bottom. So we're going to be this 120. How far can you guys, okay, you guys can only see on this screen over here. Okay, so I'm going to be right there. I'm going to move all of this up. All right, so we're going to be that inverted by 150. So we're going to go offset 0.15. Boop. Boop. And then that'll be 75 thousandths on the other. Boop. Boop. And then I think the base on this is, I think, 50, 60. 0.6. Or actually it's, I think it's right at 5/8 is what I did those at. So we'll go 0.625. So I will just mirror these. Boop, boop, by this. And then we'll trim it up. Okay, trim, boop, trim there, boop, and then do the same thing here. Okay, so there is the basic ISO grid. Then we'll just trim this over. But you guys can only see. Okay, so you guys can see that. Okay. Hold on, I gotta get that close. So if I get that closer, then you guys can't see as well. Okay. Actually, if I scoot over here, and you guys can see more of that screening. Okay. So, trim. Boop. Boop. Do the same down here. Boop. Then we'll get rid of these two little things there. And then we're going to be the same, we're going to be mirrored at this. So, copy. And then over here, and then we got to 3D rotate that. Yeah, because we're working off of the bottom, not the top. So, 180. Okay. Escape, escape. And then move this to from right there to right there. Put this back up where you guys can see it. And then we'll go to top. Okay, so then, what does that really look like? That looks like, so that's going to be parallel. So then I just rotate everything 60 degrees that way. Boop, boop, and then 60. Oh, maybe only 30. Yeah, only 30. Okay, so then we're going to be 60 off of that. Okay, so we're going to be 60 off of that, 0.06. And then to here, and then we're going to extend. I don't know, you know, I put in that video to do the Z-hop at 1 millimeter, and I think it might need to be 1.5 millimeters. I keep hearing it every so often hitting the model when it's printing. So, that's not as awesome. get rid of that. We're just going to copy that again because I didn't rotate it. Evidently, I didn't grab the right thing when I rotated it. So now it's all funky. Okay, so we're going to be the green, and we want AD. Okay. Escape. Move from here to there. Go back to top. Alright, so then I'm going to I'll extend it to there. Extend. Boop. Right there. And then move this to right about there. Alright, so that isn't the right center. All right. There we go. Now everything's lined up. So what I do, I'll just copy this. Okay, so then we're going to be over here, and I'll just copy this. Unfortunately, I didn't save the primitives on this, so that sucks. Okay, and then I think this is a 0.1. So I will just move from there to there. That looks pretty concentric. Okay, so then I'm going to go to the midpoints. So don't need this anymore. Put that up there. Then I'll just go from the midpoints to the tangent. And then midpoints to tangent there. And then trim. Trim, and boop. And then trim these, and then we'll throw a little radius on that. Like that, and then we'll do, what do we got fillet set at right now? There we go, 0.22. We can do 0.22. So we'll do that, and then this, and then we'll do radius of like, what do you think, 0.05? Probably 0.05. And then, ooh, too much. Much too much. Radius 0.02. Must not be taking my radius command. Or 0.025. 0.025, okay. That's not enough. You know, like R.05, R.05. Right, totally. Well, that's an 0.5, not a 0.5. Oh, that looks better. Okay, and then we're going to do 2 bolts. We're going to do, let's see. We'll do this in the center of the ISO, so I'll trim that. Trim, 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 boop, boop. And then we'll just do the center of the ISOs on that. And that will be, what I do that at, 0.2? 0.22? Yeah, 90 thousandths is pretty good. I use that one quite a bit. I did 0.1 on those. So 0.1, and then I did a 0.045 because it's a 440 that I'm going to use. Boop, boop. Okay, and then we're gonna copy that. Well, we're gonna clean it up first, then we'll copy it. All right, now we're gonna copy it. No, it looks like we got double lines there. We'll have to get rid of that. Okay. Now copy. Because one of these will be the top plate, the other one will be the bottom plate. So that'll be 0.055. That's the clearance for 440. Then delete the center. Boop. Boop. Okay, now we are going to go to an ISO view. Now we're going to make everything into solids. Solids, and then we're going to go extrude, or actually first we're going to go subtract. So subtract that from this, that gives us that. Then we're going to do the same thing over here. Subtract that from this. We're going to extrude this 100. 0.1. We're going to extrude this 100. 0.1. We're going to extrude these 2. 0.25, because that's 1.5 plus the 100 thousandths. Yes, I'm in inches. Okay, then we're going to go union. Union this to this to this. And then going to go subtract for those through holes. Subtract this, boop, boop. And then I need to go extrude. Evidently I didn't subtract this from there, so then we just go subtract here. Boop. Boop. Just like that, there are our parts. So then we go top. There it is. So now we're going to export. Export as STLs and send them to the printers. Oh, what are we going to use? We're going to use the K2 tonight. K2. Also because I already have the Creality slicer already set up. All right, file, export, STL. Let's see, ISO cuff, AFL, ISO cuff, tabs, T1, top 1. Now we got to go T2, ISO grid, cuff tabs, T2. Yes, and then we're going to go ISO tabs at B1, as you can imagine. B1. And B2. B2. Yep. Okay, so now we're going to take the Creality slicer and put this over here. We have to shrink up the screen a little bit. Okay, we're going to take Project CAD, put it back over here. We're going to take Creality. Put that there. This there. Okay. Huh. There we go. Okay. All right, so we have to swap this back to PLA, Hyper PLA in black. Gonna get rid of this. Don't need that anymore. Oh, actually, that is printed. So delete that. We're going to import all of the AFL parts. So documents. Where did I put those to? File, export, STL. Oh, that's in 3D models. Documents, 3D models. Those 4 and boop. Yes, scale to millimeters. Okay. That looks good. We're going to go 6 walls, and we are going to be 100%. We're going to go slice plate. Looks good. We're going to... Oh. We need to switch to the K2, not the K1. K2. We're going to... save. Yes. Okay. 100%. And 6 walls. Okay. And slice. And export to USB. Save. Okay. Looks like it's there. No green screen, that's right. Okay, back in the printer. All right. Well, that's kind of what that part's supposed to look like. I mean, it's close. This part's different than what I'm actually using, but it will work close enough for what this actually goes to. So, and as soon as the K2's done printing those parts, then we should have the whole thing. Although I need to print some bushings. This one weighs 1 kilogram, or just shy of 1. It weighs 2 pounds. Oh, I should probably charge you guys. Should probably throw you guys on the charger. Otherwise, we might have an issue coming up. There we go. There we go. Ooh, 15%. Live was almost cut shy. You think so? I mean, do you really think so? Man, I don't know. I just don't think anybody would be interested that much in my garbage. Yeah, I suppose. Okay, I'm gonna put my other phone back. I'll tell you, I have one piece of plate out there that has kicked my ass like 4 times today as I walk over it. Every time, it reaches up and grabs me. So the reason why I don't have a thumb is how would you control it? Because a thumb is actually a 2-axis appendage. You know, because it's this and then it's this. So I'm already using, you know, the 2 axes on your wrist. You can't really use supination, pronation. You know, you'd have to tie it to like your elbow, or you'd have to do like a Bowden cable up your sleeve and then tied to like a hip harness in order to really control the thumb. Unless you're going to make it a fixed thumb. If you wanted to do just a fixed thumb, you could totally do that. But really, it's all about the control. Right. Got some glue that hardened in the end of the thing. That drill bit. Yeah, I don't know. You know, the thing is, if you're missing a thumb and you're missing all your fingers, oh yeah, no, electronics are way too slow. So like I have an Oser iDigits, and it's basically 1 second to open, 1 second to close. And like when you're actually using it, it is painfully slow. And you know, you can't really, and this is just tied to basically volts, resistance, and amps. You know, if you're going to be a battery-powered device, you know, you can only run so many amps through it. You only have so many watts that are available. You know, and, you know, the motors have to be housed in the proximal. So they're only going to be a 1/2 inch diameter. So, you know, you can only throw so many amps in that before everything gets too hot. You know, and then, you know, how much battery capacity you're going to use, and just chasing that rabbit. You know, but I mean, that all becomes a thing. So, but yeah, I mean, the motor size, you know, it's just not fast enough. You know, and, you know, if you make it faster, then you're trading grip force. You know, because sure, you could make it go faster, but then you wouldn't have any load capacity on it. So, you know, right now what they sell is that they have it at a nice balance between the amount of load you can put it on and the speed. But that's because nobody designing it is actually having to use it. If they had to use it, they'd have a complete different opinion of how fast it is. So I don't know. So it depends. It depends on what I'm doing. If I'm doing what I'm doing out there, the machine shop and the sheet metal fabrication and stuff, I probably would, just out of durability. Because I can do things with this hand that you wouldn't even ever think of doing with a Mayo hand, just out of durability. It's like the other day, I was putting up a sheet of 3/16 plate. Well, that's 200 pounds that you're moving onto the plasma table. Well, on a Mayo hand, 30 pounds is the most force that you can put on it before you start breaking stuff. And for what I do, that just isn't a workable weight. If you're going to be just office living, then I guess that's okay. But otherwise, yeah, I think I would go mechanical. Mayo's cool, but it's more gadgetry, and really, okay. So like my Oser eye digits, it was billed at $85,000 to my insurance company, which is just insane. Sure, clinicians got to get paid and all of that junk. Okay, people got to make money. Oh, I should have that printer going. Hold on a second. Let me get that printer going. Right back. There you are. And print. Yes, I know. Are you printing? Yep, it's printing. All right. God, I wish there was a way I could share my... Right. So what I've actually... So I have a clinician. It's actually the clinician that took my fingers, or the surgeon that took my fingers. I've been meaning to ask her, when you're taking somebody's fingers or limb or whatever, do you do the amputation with what gear they're going to end up using in mind? And I've asked a bunch of surgeons, and they say no. That they go for, I guess, maximum retention of usable limb. And I'm just like, why wouldn't you, which causes problems, because it's like, there's a guy that I'm contemplating including in this trial. He has a part of his proximals, and really there isn't room for the proximals in this device. I'll show you real quick. So if this is all situated properly, your hand goes right up into the void space, or it should. And he still has about a ½ inch of his proximals on his middle and ring finger. And, I just don't know if he's going to be happy with it, because the internals of the fingers are going to be rubbing on that whenever they open and close. You know, so I'm like, did the surgeon, when they did the amputation, did they do them a service by letting them keep their proximals, or would it have been better if they had, you know, like in my case, taken the proximals off at the metacarpal and just he does. So it's actually Fahad Bahar. He's the guy in Qatar. Oh God, that sounds so terrible. Bahar in Qatar. He was the guy that was climbing Mount Everest that got frostbite and all that stuff. So I've been talking to him for a while now about him using my gear. And I just, you know, he's using Naked Prosthetics right now because he has enough of his proximals that he can use that as drivers. But see, he has too much of proximals to use mine to be, you know, really the way that the geometry is supposed to be. So I keep going back and forth as to whether or not I should sell him gear. Well, see, like with this device, you know, everything's, you know, to run two separate systems on that doesn't really work because you're still running the winder system to contract the fingers. You know, so it's better to just run, you know, one drive system as opposed to, you know, one for the partial fingers, you know, for the partial proximal, and then one for disarticulation at the metacarpal. So, I don't know. I do. I occasionally do. I am a real human. I need to draw this next. So, we will swap from Creality Slicer back to CAD, huh? Cancel. Boom. Back to CAD. We will go new. Alright, so we're going to be 1.312. Huh. I don't have my array. Where are my... I'm missing some of my toolbars. Let's see if I have the toolbars over here. Oh, they're underneath. I got it. I got it. I got it. We'll just make this shorter, and then I have toolbars again. Yeah, I mean, the thing is, you know, it's not like I haven't been in this space for quite a while. You know, I would like to think that a lot of what I'm doing is helping the industry and maybe, I mean, hopefully steering some of the direction of, I mean, I know that OSER talks about me. I know that Autobach talks about me. You know, it's just whether or not they're actually, you know, doing anything with it. Well, thank you. You know, I know that Chris at Point Designs, he was lobbying for some legislation difference and some things, and he was using my story as part of his thing. So I don't know. I like to think that I'm helping out the industry. I don't know. All right, so we're gonna go 1 inch, and that's, so we're gonna go 1 inch to vertex, 1 inch to the jog. $150, and then 1 inch. Then we're going to offset this. Okay, then we're going to join these back. Then we're going to offset. 0.15. And we're going to trim this too. We're going to draw this, boop, boop, and then we're going to join everything, join, boop, and we're going to make this into a solid, boop, and then we're going to throw this into an ISO, about like that, and then we're going to revolve. This will be our center point, boop, and we're going to go 360, look at that. Okay, now we're going to array this. They are not equal. They are close to equal, but they are not. Can't read the little tiny numbers. No, I guess they're pretty close. Go back to top. Now we're going to array. Item 3. There we go. I need something different than that. Oh, I guess this spool of filament will work just fine for that. Okay. So that is 11 degrees down. Awesome. We're going to explode this. Explode, and then rotate this down 11 degrees. Alright, so I need to go from here, this, there, and we're going to go red, 11. I am making some of these really quick while I'm waiting for the other prints to be done for the gimbal and Gaffney. This guy asked for these drawings like weeks ago. Unfortunately, I've just been like busy. Rotate one of these. Okay, and we're going to tilt this down so we can see that. I'm going to rotate this. Boop. From here, down 11. This is Project CAD. Yep. Oh, I mean, I can switch to solids. Just I don't know, I've been drawing in wireframe for forever. You know? Oh, looks like everything's at 11 degrees. I will just array those. Rotate. Alright, copy. Well, thanks. It is. I mean, it's pretty organic. You know, I like how, like, I can lock and unlock the ring and pinky finger and that type of stuff. You know, I haven't really decided if that feature is going to transition over into the production of it, but I like it. You know, it'll be nice once I get, you know, the trial stuff of this done. Oh, whatever. No, totally. No, absolutely, totally. Kind of. Kind of. That's funny, though. I don't usually think of it like that, but yeah, kind of. Who's making 30p an hour? That doesn't seem like enough to do anything anymore. There you go. Now you guys can see it in solid. I know a little bit of Spanish. I mean, Mexican Spanish, not Spain Spanish. Because there is a difference. Coming up next month, I better get really good at it. Adios. Are you learning Spain Spanish or Mexico Spanish? ¿Tienes unos semestre? That's cool. Yeah, I mean that would serve to be right since you live adjacent to Spain. Let's see if the printer's done. Man, those are stuck. It's like AutoCAD. It's called Project CAD. I used to run AutoCAD, but my permanent standalone license became invalidated last year. Oh, the FL Sun printed something. He did it mostly successfully. And knocked over this little bit of support. I don't know. You know, that's the only thing that I'm a little about this machine. Sure, it moves really fast and all that, but it knocks stuff over. It's like they don't have the kinematics just right. I mean, you know, it's fast, but meh. I don't know. I mean, it's pretty fast. What up? Guess it did an okay job on it. This is that Amelin dual color. filament. It's okay. The green-blue feels like it prints more dense than the red-black. I don't know. I've had a couple failed prints with the red-black. It has. No, totally. Well, today, okay, so today I am working on the IsoGrid forearm, and I just printed the gimbal 2, which goes like that, and then I just finished printing the little brackets that actually connect the gimbal 2 to the gimbal. So I have this one that I already trimmed off some of the parts. So then, like, this will end up going like that. So, but this resin isn't, this resin's only partly kicked. So, it's still kind of sticky. Next time I'll use fiberglass resin, then 5-minute epoxy that's taking like hours to cure. And then this piece goes about like that. There you go. So it'll be kind of cool. I don't know, I think I need to trim these down a skosh, probably by that 150 thousandths twice. I think those pieces are just a little bit too big. Yeah, I think I'll do that. Oh, why'd you turn off? You shouldn't be off. Sure. Okay, so I can close them. I can spread them. I can ring and pinky open. I can open and close them like normal. And I can be ring and pinky closed. So like that. Like that. And like that. Well, all you got to do is you find somebody that is missing parts, befriend them, and ask them what they would need to improve their life. Of course I can, but I haven't got my 1 million followers yet. What the heck, man? That's always been the deal. I get my gold play button and flip everybody off. That's been the deal for like 5 years. And I'm still stuck at 500,000 subs. So I'm halfway there. Try to be. I do try to be. All right, let's go make something to eat because I'm hungry. All right, we can go out in the out in the big shop. Okay, we're going on a trip. All the lights are off in the shop. I will go turn them on for you guys. All right, here is shop. That was my Rhino. Made that probably 10 years ago. There we go. You know, I've never done the cosplay thing. Never been into the cosplay thing. Be right back. Awesome. I'm glad you liked it. Okay, so did you like the CAD behind me, or should I do that different? I made an electric version of it a long time ago, and electricity was not the way to go. It was way too slow. And the other thing about the electric, it was way too fidgety. It wasn't a solid thing. You know, it would run out of batteries. It was slow. I mean, that was the big thing. It was slow. And that was frustrating to use. That was so frustrating. You know, because the motors have to fit within the proximals of your fingers. And I mean, that's a 1/2 inch diameter. I mean, it just isn't big enough for, oh, totally. I mean, but I mean, in the same, I have a pile of practice with this too. And practice makes such the difference. Like anytime that I help somebody with one of these, you know, I have to remind them, you know, hey, I have several thousand hours of practice on this. You know, because they'll get frustrated, you know, they try to pick something up and they get the closing position wrong. And then it's, you know, oh, I can't do it, blah, blah, blah. And then you're like, well, just more practice and it'll be fine. Yeah, I mean, rock, paper, scissors. Yeah, I could do that. I mean, the tail would be there. You know, if I was doing scissors. But yeah, I guess I could. Let's see. Yeah. All right, back in the studio. It is cold. It is cold. Here's my plasma cutter. Here's my press brake. There's an OBI. I'll do a quick shop. There's my little baby laser. My other laser's upstairs. Here's my Shinzo. Here's my Acrolock. A Bergmaster drill press. Got an American Turnmaster lathe. Got a Super Precision turret lathe. Got a Do4 Universal. Got a Lapmaster. Got a D2 decal. Got an Acra tool and cutter grinder. Got a Harig surface grinder. Got a Toast Karim milling machine. A couple toolboxes. A bunch of toolboxes. Got a couple welders. Got just a bunch of gravity in here. Great big pile of gravity. And it is so much warmer in the studio. So much warmer in the studio. All right. Thanks. All right. There we go. Thanks. I appreciate that. I try to be pretty decent. Oh my God. All right, well, got a couple little things printed today. I got that printer still working. This would be so cool if I could get it to work. Because then I could just print these in carbon fiber, you know, carbon fiber nylon or something like that. And then it wouldn't be such a custom piece. You know, and that would be awesome. So when okay, so you know I'm doing that. I gotta stop calling it a trial because it's not a trial. A trial is a FDA regulated thing. I started calling it like a market survey of my device. When I do that and I start making the hard assets for the hard video assets for how to put the kit together, I think you'll see how it all goes together better on that format, because like I'm going to start doing the assembly videos as like a series. Like I'll do a live with the other people that are going to be putting them together for themselves. And it'll be like one night we put together fingers, you know, or a finger, and then put together the display linkage and then the winder. So then after they have all that together, you know, they'll have most of the hand. Then it's just the Gaffney and then the gimbal, the part that I'm working on tonight. You know, so we get all of that going. And I think it'll be pretty good. I don't know. Sometimes I get frustrated about it just because it seems like it's just going so slow. You know, that the project is just taking so long to get off the ground. But, I mean, type of thing takes time. I mean, what I would do, I would just hit him up going, hey, you know, is there anything that I could make you that would help to improve your situation? I mean, like that Aaron kid that I made the crab clamp for. You know, I had talked to him a zillion times at the place I go to lunch. You know, he works at a Carl's Jr. in town. You know, and I'd talked to him a couple times, and it's just, hey, you know, would it help you if I made you this? You know, and he was like, well, yeah, it'd help me if I could do this and this and this. So, yeah, pretty much. All right, we need to change that. We need to change that drawing. Awesome. Well, happy Thanksgiving to you as well. Okay, so the way I lift heavy objects is I lift off of the back of the distals. Because the way that I have the geometry of these fingers, the way the geometry of this finger is, if you put load on the back of here, you can put all kinds of weight here and the fingers won't open back up. So that's how I end up picking up like that video of me picking up 110 pounds. I'm picking up on the back of the fingers like this. I'm putting weight here. And ultimately that all translates to how much force you can put on the back of your hand, on the back side of the thumb, because everything goes in suspension at that point. It's not like your natural fleshy fingers, because all of that is all translated to the inside of your hand. Whereas on this, everything is really held by the suspension of the thumb. Sorry, it's like 5:30 here. I'm hungry. I didn't have lunch. I had an apple. It isn't very good, but it's what I have in the refrigerator at the shop. Hands are magical. 26 degrees of freedom right there. That is just magical. So the problem is, as cool as it is, there isn't enough of a market for it. And that's why the insurance companies, and why like Osir and Autobach and all of them, why they haven't done anything really for the partial hand market, just because there isn't enough of a need for it. But for those that are, for the people that need it, it's the only thing that will do. But there isn't enough of a draw for it to make. It's called ROI, return on investment. So in order to make a device through the FDA and all that junk, I'm looking at like $2.4 million. Well, I'm not going to put $2.4 million into anything. So that's why like Osir and Autobach haven't done it either, because there isn't enough of a. So like with a hand, there's like 60 different iterations of the way a hand can be amputated. Anything from, just like say the distal of your index finger, which, you'd wear a thimble or you wouldn't do anything for. But, it depends upon the use case. The problem is that, hands are truly, the devices for hands become so individualized and specialized that making anything commercial just costs $1 zillion. And that's really why you don't see much activity in this market sector, is because there's so much customization that would need to take place. Oh, yeah, no, but that's the way it is everywhere. It's always comes down to the profit. And it's I think it's tragic that it all comes down to the dollars. Because I've seen a lot of great devices, a lot of them are overly complicated, but still great devices that you're just like, oh, this would be awesome. Well, so the only reason why I'm doing it as DIY, I mean, there's a couple reasons why I'm doing it as DIY. One is the legal, the legal avenue of it, but that's just so I don't get sued and go to jail. But yeah, I don't know. It is frustrating. It is really frustrating. Because then you have to find the right person that has the skill set to do this as a DIY. Or, or they want to, so it takes about 40 hours to refine this, to put it together to where it's, all one piece. Well, I get $150 an hour at the machine shop. So that's $6,000, and, amputees have this weird idea that, because something tragic has happened to them, that they are owed a device. And, it really isn't that way. So a lot of amputees that I've met, I know it's probably just isolated people, but they're like, I'm owed this thing. And it's like, well, I still have a bunch of money in this, so I need to be paid for this. So, I don't know, it gets weird. It gets weird with insurance and money and all that junk. I don't know. That's my take on it. Yeah, I mean, this device is... So the reason why no is because... Okay, so, like, say if you still had a portion of your proximals on your middle and ring finger. Okay? So this device wouldn't be ideal for that because, like I said before, if it's properly fitted, there's no room in the device for your partial fingers. And in order to get the geometry where it closes correctly, this part's got to be right up against your residual limb. So I think really the problem comes down to the surgeons, that they're, that they aren't amputating with a specific device in mind, that they're amputating to give the person the most amount of a limb. Whereas, if they would look at it going forward to their future life, I think that they would possibly do the amputations differently. It's like, if someone had, say like on, well, I mean, I don't know. Right, because, I mean, the surgeon can set the pace for anything. Of course you want to give the person the most amount of residual limb back. Okay? I mean, it's like, say someone, amputated their distal. Okay? So they're probably not going to do anything for that. They would leave the medial and proximal, of course, and someone can operate without a distal. Okay? But, say something happens to the medial, they're going to leave the proximal. Okay? And for that, you'd use like a naked prosthetics PIP driver. Great device. All mechanical. Okay? And it just slips over and you wear a wristband. I've actually been working on a 3D printed version of that on and off for a while. The problem I run into that is getting everything small enough and strong enough for real world. And that's really the problem. It's like you could 3D print something, but 3D printing really isn't strong enough for what this is. I mean, plastic 3D printing, let me say. Because, like, you know, these are all 3D printed from PCBWay. These are the these are all the fingers and parts. Like, here's all the, what are these? These are all proximal ones. Here's a bunch of medials. Here's a bunch of distals. And then here's some winder parts. I actually have to start putting together a kit for a couple people coming up. I'm going to try to send off the kit before I go to Super Bowl. Hopefully I'll be able to do that. They do, but when they do the amputation, they don't do it with a device in mind. You know, it's like, I think, I don't know, it's just tough because, you know, then surgeons, I don't know. You know, I mean, it's like, for myself, I think I would have had more comfort going into it. I mean, keep in mind, you know, when I had my amputation, you know, because they took each one of my, you know, they took each of my fingers one at a time. You know, because we were trying to get ahead of a bone infection. Because that was like right after my stem cell transplant. But say something that's, you know, a traumatic injury, you know, if you were to meet with, you know, the person, and then it's like, okay, and this is the type of device, you know, would this device, you know, suit your life going forward? You know, and then I think if they could tailor the amputation more towards that device. Because, like, the surgeons that I've talked to, they have no real idea of what's available device-wise. You know, it's like these two separate worlds. You know, you have the surgeons fixing it, and then you have the prostheticians that are like, what am I supposed to do with this? You know, and what I mean, also, I mean, you have the same thing, you know, if someone heals with like a skin flap, or they have a bunch of keloid scarring or that type of thing, then that's going to be, I really think so. I mean, I mean, I know they do that in lower limb, you know, for like legs and stuff. I need to move you guys because I can't really read that. I need a thing. Oh, I can use the microphone. I can use the microphone box. Yeah, I don't know. Next time I talk to my surgeon friends, I'm going to be like, hey, what do you think about, you know, and just see if, you know, see if that's something that they think about, or if it's something that they're taught, or they, you know, they could think about like that. You know, because, I mean, it's difficult. You know, I don't know, I mean, the difficult thing is, you know, you're in the middle of a traumatic situation. You know, you got somebody that's, you know, that's all broken, and you're trying to put them together. Oh, let's see what I got for parts. Any models available for what? I should sell these. These ended up not being the right ones. These are, though. Oh, of this? So yes and no. So I've ordered parts for the first batch of people that are going to try building them. Right. You know, I know that they do it for lower limb. You know, and the way that they reconnect the muscle, you know, because they'll connect the shin muscle to the calf muscle to where you can get kind of a sense of proprioception. And they don't really do that for the hand, per se. I mean, I guess some of it depends upon the surgeon, but, you know, for the most part, they don't really do that for the hand. That's a pinky. See, that's how the finger's supposed to, or how the proximal setup is supposed to interface. This is still a little bit tight, but it's pretty close. That's how it's supposed to go. I don't think I have enough of... I don't think I have a full hand worth of parts right now. Dang it. Right, but they should be. You know, because, you know, when you're, you know, taking parts off, you know, you have to have something in mind for your patient to go forward with. You know, it's like, okay, if, you know, it's like, okay, if, say like for me, had they been able to leave the proximals of my fingers, I would have a completely different device. I would have a completely different set of devices if I was left with my proximals. Whereas where they took my proximals to the metacarpal, you know, that eliminates a bunch of options. You know, or you know, even if I was to be able to retain, like, say, half of my proximal, you know, I would have a completely different set of options than if you have no proximals. You know, that's kind of the big line in the sand. You know, or say, so like with mine, we ran out of skin, so we ended up stretching a lot of the skin from my palm and, you know, doing some, not grafting, but some drugs that make your skin grow really, really, really fast, which is awesome. But you know, when the surgeon's doing their thing, they're really setting the pace and tone for what the person is going to be able to do in the future. So I don't know. I just think more forethought needs to go into that than kind of where it is. I don't know. Of course, I mean, that's just me thinking too. You know, I mean, and everybody's going to be different. Right, right. Well, I mean, it's like mine. You know, okay, sure, I broke my hand. Things were bad. You know, but I mean, for the most part, you know, the initial part of the surgery, okay, that was traumatic. But everything subsequent to that, you know, I showed up. They said, "Oh, you aren't looking like you're healing anymore. You're scheduled for emergency surgery tomorrow." So, I mean, it was something that, you know, I mean, in my case, we were trying to get ahead of an infection, which, don't get me wrong, she did an awesome job, and I'm very glad for everything that she did for me. Yeah. No, I mean, there's a lot, because at the time that they're doing surgery, they are setting the the tone of what you're going to be in the future. Of course, primarily they're trying to save the patient's, life, limb, whatever. But for the most part, I mean, they have a lot of options that they could do. All right, let's see how many of these we got. I think we should have 12 of these. Okay, there's one. I need to order all of these before. No, that's video game logic. See, like what we've been talking about earlier, say you lose all of this finger and you lose to the proximal on the other three fingers. Okay? So that's a completely different, you wouldn't use this device. You wouldn't use anything like this device, even though you lost all of your index. What you'd use is an MCP driver because those are driven off of the proximal for this, and then your index finger would be driven tandem off of your middle finger. So your middle finger would just have another finger sticking off to the side of it, and when you move that, then your prosthetic index would move the same. And same thing if you lost, middle and ring finger at the metacarpal, and index at the proximal, pinky at the proximal, you would reverse that. Or you could do a wrist driven for the middle ring, and then proximal driver for the index and pinky. I mean, the thing is, there's a lot of different directions that you can go with the device, but I don't think surgeons are looking forward when they're in the surgery center making those decisions for that person. Okay, so it's like, the guy Mark that I help out, he was left, his hand's like super fucked up, and had the surgeon ended up taking all of his pinky, rather than leaving him kind of with a mangled up pinky, he would have completely different choices. I mean, it's like, I have a guy in, I think he's in Israel, and he has, so I think he has like half proximals for his index, middle, and ring, and he has so I don't do coffee or any of that type of thing. I don't know, I mostly drink water. I mean, I guess I'd go Dr. Pepper. Diet Pepsi. I like Diet Pepsi. Diet Pepsi's good. But he has parts of his proximals and most of a fucked up pinky. Okay? So, had his surgeons, taken everything off at the metacarpals, I would be able to help him out with my device. But where he has not enough of his proximals to use PIP drivers, and his pinky is just a train wreck, that should have been just taken off, or, it's all twisted and just blah. um, had his surgeon done different things, he would have, you know, different options going forward. But the problem is, that was probably a dozen years. That was probably 10 years ago now. So, now he's all super healed. And it's like, I've talked to him about, hey, what do you think about having a revision surgery, to clean this up? You're way past, your traumatic incident. If you were to go and have this revision surgery, then I could help you out with this. Well, he had to go through so much trauma mentally that, he's like, oh, I can't do surgery again. It's too big of a thing. So, which I get, but if he had this revision surgery, then, then he could use this and it would further him going forward in life. But he'd have to do that, big scary surgery thing again. I mean, if it were me, if I was in that situation, oh, I would totally lop what he has off. I would just, boop, done. Because then it's like, oh, if I do this, then I can have a functioning hand? Totally. Yeah, they're hand specialists. It isn't all traumatic surgery. I am short a pile of pieces. I think I have enough to make one hand. Let's see. We got a middle. Okay, we got 2 middle fingers. 2 middles. Nope, I only have enough to make one hand. Okay, so I have an index and a ring. So index and ring and a proximal 2 for an index and a ring. I have 4 medials. Okay, and I have a pinky proximal 1 and a pinky proximal 2. Oh, I only have 3 distal links. So I would have to make some of those. Only have 3 distal links. I have 2 chains set up. I think these are the wrong ones. Nope, that's the right one. Okay. Distals. So I got 4 distals. Okay, so all I'm missing are distal links. And pins. So I don't think they're forward thinking enough. I think they're caught up at the time with, I got to fix this and that's it. Okay, and we got 4 metacarpal bases. And these are the modified ones. That one is not modified. That one is partially modified. I thought I had some more of these. It is. There are way too many variables, and that's where the problem with making this into a commercial venture lies. Because it isn't a one size fits all or a one situation fits all. Heck, it isn't even a one situation fits most. I mean, so like, uh, mine is for very specific disarticulation at the metacarpal level, no proximals. Asterisks. Okay? So I am helping a couple people that have part of their proximal, like just like a half an inch of their proximal. And, honestly, that's been very plus or minus for success because this part of the hand doesn't seat deep enough onto their residual limb. So then the loading gets weird. How the fingers close gets weird. How the thumb ends up crossing the medial of the finger gets weird. So, there's a bunch of asterisks that has to go with it, which I don't know. It's tough talking to people. When people call me up and go, "Hey, I want one of your things," and then it's like I had a guy a couple weeks ago and argued with me about it for like 2 hours. He was trans metacarpal, so he was, half his metacarpals were gone. And it's like, you don't have enough residual limb to be stable with this. You don't have enough residual limb that, that the geometry is going to work with the fingers, and that what you have is going to seat on the mounting rail. And he's like, "But I can move my wrist and I have my thumb." And it's like, yeah, but you don't have enough of your palm. He essentially didn't have a palm. And, that's tough. Right. So, and hand is such an important thing, you know, um, not only just socially, but, to do, to do stuff, just to do work, to be out in the wild. I mean, no, this is for, so yes, okay, so mine is a 3-stage finger, medial, proximal, distal, or distal, medial, proximal. So you could make it to where it only has a distal proximal, to where it only has 2 sections, that actually articulate. That would simplify it, but that would affect how the grip is. You wouldn't have as natural of a grip. You also wouldn't have a natural looking grip. Everything's very, like that, rather than, actually working like your hand does. So, but, and then as far as, this is about, the only fluffy things that I have on here is, of course, the splay, but I find that I use the splay quite a bit, and being able to lock and unlock the ring and pinky finger. That's really the only fluffy stuff that I have on this. But I don't use the ring and pinky lock as much as I thought I would. I do use it, but not as much as I thought I would. So that's something that I keep bouncing back and forth. Is it worth the complexity in the device to incorporate it into this market survey device thing? Yeah. Well, but it also is determined by the amount of effort that the patient is going to put into their life going forward. I mean, okay, so like my grandfather. Okay, he was what, 25-year insulin dependent diabetic. Got a cut on his legs, ended up, you know, they did the slow chop, toes, then a foot, and then, finally below the knee amputation. Okay? And, you know, at the time, he was having a bunch, he had a stroke and then Bell's palsy, a whole bunch of stuff. But, had he been younger and more hanging on to life, they would have fit him with different devices, because it's like, I mean, even like this, I could fit somebody for this, and if they aren't going to put in the practice of how to use it, if they aren't going to put in the 1,000 hours to figure out, how to pick up, little tiny stuff, how to, then it does no good. If they aren't going to wear it every day, then it's, then it's a moot point. But if you have someone that is physically active and, this is going to be an integral part of their life, then absolutely it is worth every bit of technology that can be thrown at it going forward. I mean, it's like I wish that, there was something commercially available for my situation, but what is commercially available doesn't fit for my lifestyle. I'm still very physically active. I still do a lot of, I still do a lot of stuff, and, so it really comes down to the patient. But I mean, I think those are conversations that need to be had with the surgeon kind of going forward to kind of really make the different decisions. I don't know. It's an odd thing. But I think that they need a different direction than what they're doing now. Yeah. Well, I mean, like what I've been figuring, it's like, as great as this is, finding the people that are interested in, and also, you have to want this aesthetic too. Not as cool as I think this is, not everybody wants that aesthetic. And that's difficult. So then, what are you going to be designing for those people? I mean, that's tough. That is super tough. All right. So I still need... Right. Well, and honestly, I couldn't imagine using not my gear. I mean, I will always, I will forever wear gear that I designed and made. Yeah, I mean, I just couldn't imagine it different. And that's odd. And yet, yeah, I don't know. I mean, I've talked to a bunch of clinicians, and it's an odd idea. What so right now I'm working on the modification for the forearm cuff. So this is the current printed ISO grid one that replaces this. And the parts I'm doing right now are the clips that go to the gimbal 2 that would make this modular to this piece. That's what I'm currently designing. So it would go, instead of on this piece, it would go to this piece. So it'd be the parts that connect this to this. And those are these little black ones. That's the part I'm designing right now. So I'm actually taking 150 off both sides of this, and then I'll reprint them. These I think these are okay. This is the mate to it. They have a 150,000 standoff, and then they would bolt together, and then they sandwich this piece. Boop. So, but I'm trying to get this to where this could be a 3D printed component that wouldn't need to be custom. You know, I'm trying to get away from as much, you know, super custom parts as I can. So it looks like I have one set of fingers minus pins. And I guess, so here's one that has mounting rails on it, so I guess I could send that one off too. I ordered new metacarpal bases last night, so they ought to be here in, I think, 10 days. Yeah, I've made the plastic proof of concept ones. The problem with the plastic ones is the plastic just isn't strong enough. You know, they break at the layer lines. You know, plastic just isn't strong enough. But like early on, I did the proof of concepts on this. If you look back in my videos, it'd be like December of 22, I think, is when I started on the AF series of hands. And I ordered these last night, so we'll see what those look like. I don't know if they're going to be strong enough in printed aluminum or magnesium aluminum. You know, I mean, the other issue that you run into is, you know, like on this reversing link right here, there's a lot of leverage that gets, there's a lot of load that gets put onto that. You know, there's a tremendous amount of load that gets put on into those parts. You know, and like early on, I tried doing them out of plastic, and it just flat was not strong enough, like at all. You know, even using like, you know, PA6 and PA12, you know, the nylon just wasn't strong enough. You know, you still end up with layer lines. I mean, I even tried we'll do 0.6. I even tried resin. I tried resin a long time ago. Um, and resin was strong for like a week, and then they would just break. They would shatter. And that's the last thing. That's ABS is what Legos are made out of. Yeah, that's pretty much exclusively what I print in is ABS. I don't, ABS or nylon carbon fiber is what I mostly print in. The only, PLA and that type of thing that I do is just whatever, like the printer companies send me. I don't order PLA. Oh, so how am I going to do that? Yeah, well, I don't know. It's a thing. So absolutely, I would to have it all machined. Here is the issue. Um, so like, the medium, right here. Okay, so this medial on my fourth axis, starting out with a piece of 1 inch round. Okay, so you cut the profile, you cut the trough, you cut the windows, you pop the holes, you cut the other window, and then you part it off. Okay, that takes roughly 17 minutes to do all those operations. So, you're looking at call it $40 to machine it. I can get these 3D printed out of mag aluminum for $7 a piece. So, that's the big reason why I'm doing the 3D printed out of mag aluminum is just the price. I mean it's like, okay, so like the metacarpal bases, okay? I've tried machining this on the fifth axis, and I can get these printed out of PCB wave for I think $19 a piece. That's cool. Yeah, so but I can't even do an op zero on the blank of this for $19. And I can get, this. Now, like the winder parts have to be machined because 3D printing in metal is not the same as machining. The tolerances just are not there. Like I tried doing the winder assembly as 3D printed and could not make it work. So like this winder is like $400 for the components for this winder, which is still cheap. Don't get me wrong, but if it was all 3D printed out of even mag aluminum, it'd be probably $150. But because I need the precision in it, it's got to be machined, so it's way more money. Um, so all of the parts to the kit. So this bag of fingers, and then the gaffney, and then the gimbal is right at $6,500. So, and then the chains and the pins and all of that junk is right about $6,500. So, I mean, I have a zillion dollars in each one of my hands. I mean, in just hard cost, aluminum bearings, end mills. Each time I do one of these, it costs me $2,000 just hard cost, just for the materials. And that doesn't count any of my time. So, it's expensive. It becomes expensive. Right? But, I mean, also figure, in a design for a device, I'll have, like, I for the initial design on this device, I probably have 1,500 hours, just coming up with and prototyping and all of that. So, I have $225,000 in time developing this for me. So, $250,000 is what I would have to charge to design this for somebody. And then there's no guarantee that they would like it. That's the tough thing. I mean, so like in first week of December, one of the guys that's putting together one of, that's going to be getting one of these, he's coming out for the day, and he's gonna wear one of these for, a day to see if he likes the feel of it, because he might put it on and go, ooh, I really don't like how this feels. And it would be way better to figure that out early than to get, done with it and then go, right, but it's time. I mean, it's 1,500 hours. It's 3/4 of what, an average person's work year is. The average person works 2,000 hours in a year. So that's 3/4 of a year worth of work. Yeah. But you got to remember, I'm starting from zero. You start from nothing, and then you have to generate all of the drawings, then you prototype it, and then you iterate it, and then you get it to where, you got to figure, I've been working on this version for 2.5 years now. So that's roughly 5,000 hours. I mean, that's $600,000 worth of billable time on this. If you're talking like down to circlips and that type of thing, there's probably 150 parts. You know, if you get down to circlips and individual bolts and that type of thing. I think I'm going to radius that at 0.1. Oh, yeah. Well, I mean, you know, the reason why I'm so dedicated to it is because, it directly affects me. If I was, and I think that's why you don't have a lot of development in this sector, because, I am kind of a rare find, someone that is someone with an engineering design background that also has a machine shop so they can prototype it, that is also an amputee. It's because, like, in my, market research, all of that. Awesome. Nice to meet you as well from Jakarta. So, a lot of the people that you see on YouTube and I'm going to change the world and I'm going to build this, partial hand prosthetic and I'm going to, which is great. Don't get me wrong. They kind of fizzle out because it doesn't directly, impact them throughout their life. File, export, STL. We're going to do bottom 1. Yeah, I guess. I mean, you got to remember mine is because of blood cancer. So, no, this is all my artwork. It's all my artwork. Yeah. It's kind of just whenever I think about it. I'm trying to do it more often. I'm trying to do it at least once a week. It'll generally be on a Tuesday. It'll be on a Tuesday, or I think I've been doing Sundays lately. I did the Saturday during I think it was the Tyson fight. I did a live on that day, and that was kind of fun. I had my other phone set up here, and we were watching the fight at the same. Well, we were watching whatever you call that. It was hardly a fight. But that was kind of fun. Feet. I'd rather lose my feet than my hands. And the reason is because Yeah, right? It was awful. I mean, it was just flat awful. All right, so we're gonna print those. We're still at 100%, 6 layers. That will print in 13 minutes. Gotta say, I'm so glad that I am doing stuff with Quality and all them. They have been such a good company to do work with. You know, and like their scanner, I didn't realize how good their scanner setup was until Maker Pro sent me one of their scanners. And God, I am trying so hard to like it, but it is. Right. No, that was an awful fight. That was terrible. Oh no, this part turned out so good. I mean, look at that. Isn't that so cool? Yep. So close. It's still just a little bit tight. I need to change the angles on a couple of the parts. I gotta start machining these the display linkage components probably on Friday. I do okay. I do okay. I mean, I work in a steel shop, so you know. I don't know. So do you guys only like ones that are in the studio, or do you want lives that are out in the shop proper? Like if I were machining these, would you guys want to watch that or no? What do you think? All right, while I'm waiting on that. Oh, is that not charging? Well, shoot. All right, we got full battery there. Didn't look at my phone was charging. Whoopsie. Okay. We're going to go out in the shop, and I'm going to see it's 7 o'clock now. We'll cut out some mounting rails. I think I got some material to do some mounting rails. That's an easy program. We'll cut some of those out. Because I think those are in their final iteration as well. Okay, so we need air. We need power. We had a power blip earlier today, so all the machines shut off, which kind of sucks. Oh, Control F1. There we go. Okay. So do you guys want to watch the machine, or do you want to watch me? Let's see, I can do... Okay. Okay, well, thanks for coming and hanging out. All right. Go Mach 2. Mill on. There we go. All right. That is Windows XP. Windows XP is solid. Okay, so that is going to be X and Y. That is Z0. Okay, we are going to make mounting rails. Load G code. mounting rails. So this is 6x2 6063 T6 that was dropped from a job that I was doing a couple months ago. So you got to figure 6x2 is actually 14 inches linearly of aluminum. So I'm just machining up the drop. All right, so X and Y, and here we go. There it is. I guess I can move you guys closer to actually see the milling machine go. That's cool. I'll hop on the live on my other phone. I take it that wasn't as much fun as what everybody thought it was going to be. Sorry. Machining isn't that much fun. But now I have another set of mounting rails that's machined out, so yay me. All right, well, I think since we only have 3 people, I think I'm going to call it for tonight. Thanks for watching. I enjoy you guys hanging out, seeing what I'm doing, and talking to me. All right, I'll try to do it more regular for you guys. All right, thanks for watching.